Hello everyone, let's solve a problem from GATE 2022 Aerospace Engineering paper, question number 50. So a rotational velocity field of an airflow is given as V vector is equal to Ay vector plus Bjj vector with A is equal to 10 per second and B is equal to 20 per second. The air density is 1 kilogram per meter cube and the pressure at x, y is equal to 0, meter is 100 kilopascal. And neglecting the gravity, the pressure at 6,8 is equal to dash kilopascal. Okay, so we have been given a pressure at one point and we are asked to find the pressure at the another point. We also have been given a velocity field as Ay in x component as a x component velocity and Bx as y component velocity. We just have to find the pressure at 6,8 and we just have to neglect the gravity as well. Now let's use the Navier-Stokes equation to solve this problem. Let's go and solve the problem. So we have been given a velocity field Ay plus Bx j vector and A is given as 10 and B is given as 20 if we substitute that. So we'll get we'll take u as the velocity in x direction, that is 10y, and v as the velocity in y direction, which is 20x, right? Now let's and we have also been given that the density of air is 1 kilogram per meter cube, and then the pressure at 0, 0 is 100 kilopascal, and we have been asked to find the pressure at P at 6, 8, right? We have to give the answer in terms of kilopascal. Now let's use the x momentum equation in two-dimensional form. Since we have only two velocity components, we don't have the velocity component in the z direction. We'll just ignore the z components, which will anyway be going to become 0. We're just ignoring that z component in the Navier-Stokes x momentum equation. We are also neglecting the body force term, and in the question we have been asked to neglect the gravity, right? So we are also ignoring that gravity part. Okay, and since we don't have any terms having t in u and v, our unsteady term will become 0, okay, in both x and y momentum equation. So this term will become 0, and let's find dou u by dou x. So if we differentiate u with respect to x, that will become 0, and if we differentiate u with respect to y, that will give us 10, right? So now let's substitute that in the equation, and since we have the constant values in the first derivative, all of their second derivatives will become 0, okay, because the differentiation of constant is 0. So the unsteady term becomes 0, and then this term becomes 0 as we can see here, and all our viscous term will become 0 because we have constant values in the first derivatives, and the differentiation of that will become 0, and hence we don't have any second derivatives. Hence we end up with these two terms. Let's substitute the values of these two terms, and instead of v we'll substitute 20x, and instead of dou u by dou y we'll have 10, and we have 1 by 1, and dou p by dou x is we don't know that, right? We'll just keep it as it is, and consider that p is function of only x, and we'll just convert that into dp by dx and bring that dx into the left hand side. So we'll have one side as in terms of x and the other side in terms of p. We'll try to integrate to find the p value, right? So if we integrate dp, we'll get p, and if we integrate x dx, we'll get x square by 2. So this 2 and 200 will get cancelled, will give us 100 x square, and c1 is the constant of integration, right? So we'll have p is equal to minus 100 x square plus c1. Okay, this is one equation that we are getting. Now let's try to use the y momentum equation as well, right? This is the y momentum equation, dou v by dou t plus u dou v by dou x plus v dou v by dou y is equal to minus 1 by rho dou p by dou y plus nu into dou square v by dou x square plus dou square v by dou y square, right? So here also our unsteady term will get cancelled, and our dou v by dou x will become 20 because we have a function as 20x. the differentiation of that with respect to x will give us 20, and differentiation of v with respect to y will give us 0, since we don't have any terms in terms of y, right? So this will go to 0, and our unsteady term will go to 0, and this term will also go to 0 because of this, and our viscous terms also will go to 0 since it contains the second derivatives. As in the previous case, we have the constant values in the first derivative, and hence the differentiation of that will give us second derivative, which will eventually become 0, right? So we end up with these two terms similar to the x momentum equation. We will substitute that. U is 10y, and dou v by dou x is 20, and minus 1 by 1 dou p by dou y. So we are doing the similar procedure, and we will end up with again integrating on the both sides. Here now we will integrate with this with respect to y, hence we get p is equal to minus 100 y square plus c2, right? So since we have two equations, we will just combine that into a one equation, and we will just write minus 100 x square minus 100 y square. We will take these two constant as a one constant as c3, right? So now we have a boundary condition that P at 0, 0 is equal to 100 kilopascal. Let's substitute that, right? This is what we have. If we substitute that in the above equation, you'll get 100 into 10 power 3, since we have kilo here, 100 into 10 power 3, and this is 0, this term is also 0, and we have C3. So totally C3 we have C3 is equal to 10 power 5. Okay, this is what we have. Let's substitute again into this equation. We'll end up with p is equal to minus 100 x square minus 100 y square plus 10 power 5, right? So we just need to find p at 6 comma 8. So instead of x we will substitute 6, and instead of y we will substitute 8, right? Let's substitute that. P at 6 comma 8 will give us minus 100 into 6 square plus minus 100 into 8 square plus 10 power 5. Since we have to give our answer in 10 kilopascal, we will just take 10 power 3 outside. Okay, so if we take 10 power 3 outside, we will get 3.6. 6 square will give us 36, and 8 square will give us 64. Here we are taking 10 outside, right? So that will give us minus 3.6, and here we'll get minus 6.4. This both adding up will give us minus 10, right? And we have 100 here, so minus 10 plus 100 will give us 90, right? So 90 into 10 power 3 Pascal is the answer. So since we have to give the answer in kilopascal, we'll just take this 10 power 3, and P at 6 comma 8 will give us 90 kilopascal, right? So our answer for this question is 90 kilopascal, and the NPTEL reference for this particular question is from the course Advanced Concepts in Fluid Mechanics by Professor Suman Chakravarti in IIT Kharagpur. You can see the link for the course web page here, and the particular video that you want to refer to for the Navier-Stokes equation is from week 2, lecture number 16, Navier-Stokes equation continue. You can also have a look at the previous video, which is the continuation, which is a continuation of this video, right? And the YouTube video for the particular question, particular lecture is also given here. So that's all for this question. The answer is 90 kilopascal. Thank you.